Algebra 2, Lesson 33, Major Rules of Algebra and Complex Fractions. So what we're doing here is we're just applying some rules of algebra to simplify these complex fractions here and here. We'll start with A. The first thing we want to do is simplify this numerator, since it's written as a polynomial in integers. So our common denominator is going to be ZP, and this first term is missing the Z. So we'll start by multiplying that by Z over Z. So that changes our numerator to mz plus 3, and then we can write it all over the common denominator of zp. Once we've done that, we just have to use our all over s over p. We're just going to use our complex fraction rule and then invert and multiply by the denominator. So the denominator turns into p over s, and then we multiply. Before we multiply, we need to look for cross cancellation. We can't cross cancel anything here because this is a polynomial and they don't have any of the same numbers. Here we can cross cancel. We can cross cancel the p, and so then we're just left with mz plus 3 over sz. And that's our final answer. B is a little more tricky because we have a more complex denominator. Again, we want to simplify this numerator because it's a polynomial of terms. And we see that our common denominator is going to be m parentheses a plus m. So to get to that, we multiply this one by a plus m over a plus m. And this one we're going to multiply by m over m. When we do that, this numerator is going to become my. And this numerator is going to distribute, and then we get as and then ms. So now that's our new numerator in the overall larger fraction. From here we apply our complex fraction rule. We're going to take this one, invert, and multiply. So then we have y plus s over a, and we're looking for anything we can cross cancel here, but I don't think we can. So we've got a polynomial, these don't match. There's no a we can factor out of this, so we're just going to have to rewrite it like this. We'll rewrite the denominator as a times m parentheses a plus m. And the numerator is going to get tricky because we have to do some foiling. And I'm going to go ahead and write this up here so we can simplify it and put it down here. Y times my is going to give me my squared, times as is going to give me asy, and then times ms is going to give me msy. Now the s, when I multiply by that, that's going to give me msy. That gives me as squared and ms squared. Okay, so this is pretty confusing, but if you look closely, you'll see we have two like terms right here. We have two msy's. Those combine to become two msy, and everything else is different. So we'll go ahead and write this with the highest coefficients first. Let's see here. That's going to be, we'll just do my squared plus as squared plus ms squared plus 2msy plus asy. So that's one way we can write our final answer. Now you guys are going to love the second way. The second way is great because you don't have to multiply anything. The second way to do it is to just leave the numerator as these two polynomials. So going back a couple of steps, you'd have the common denominator of a plus m, and instead of doing all this distribution, you can just simply leave them as separate polynomials. You can do y plus s times parentheses my plus as plus ms. This is probably going to be your guys' most preferred method. It's less work, you don't have to worry about combining like terms, and it's still pretty easy to read as an answer. So for the record, if you go ahead and distribute and simplify. That's not going to be wrong, but most of the times the book is going to prefer the answer in this form down here, and it's less work. And that's all we got.